Hello everyone, my name is Ananya P. Tamkar and I am a student from Sri Venkateswara College of Engineering. In this video, I shall be talking about list-based structures for efficient pattern mining. The agenda for this video is abstract, introduction, literature review, model architecture, methodology, results and conclusion. The research paper which I have referred is called Incremental Top K High Utility Pattern Mining and Analyzing over the Entire Accumulated Dynamic Database. There are more papers which I have referenced and I have listed them in the video. If you are interested in knowing more about efficient pattern mining list structures, you can click on the link which I have provided in the description. Pattern mining is a technique in data mining that focuses on identifying recurring patterns, associations, or structures within large data sets. It is used to discover meaningful relationships or trends and help in decision making, prediction, and helps gaining insights into the data. High utility pattern mining may aims to discover patterns with more profit importance rather than frequency alone. This is useful in applications like market analysis where the patterns change over time. Top K utility pattern mining extracts highest top K patterns that users want to find. Many methods and algorithms have been generated for high utility pattern mining and cannot handle incremental databases. They have the limitation of processing a portion of the database rather than the entire accumulated database. This paper suggests an efficient mining method which utilizes a list structure that stores minimal utility information required for the mining process and does not generate candidate item sets. Traditional pattern mining methods receive a threshold from the user to extract result patterns. When threshold is too low, we receive an extravagant number of patterns which increases runtime and memory usage. When threshold is too high, we might receive very few or no patterns at all. To solve this problem, top K pattern mining algorithms have been proposed. Instead of threshold, they receive K, which is the number of patterns to be extracted. Therefore, they can extract an ideal number of patterns without complicated threshold adjustments. The amount of accumulated data and the speed of accumulation are increasing rapidly. In such situations, real-time inserted incremental data must be scanned once. An efficient incremental top K high-utility item set mining algorithm is proposed to discover top K high-utility patterns from accumulated incremental databases with a single scan using a list structure. Now let us look at the model architecture. The pair top K high-utility pattern mining methods scan the entire accumulated database twice and construct the data structures from scratch. However, the proposed algorithm scans just the inserted database portion once and updates its data structure accordingly through a restructuring procedure. It also introduces a database restoring process which enables different efficient threshold raising without the rescan of previous data. Thus, the algorithm has the advantage over existing methods in that it does not suffer from overheads in scanning massive amounts of previously accumulated data. This is an overlook of the overall process. Now I shall be explaining the methodology of the algorithm. The algorithm scans the original database to calculate utility values and transaction weighted utility of items. It applies the raising the minimum utility strategy to set an initial utility threshold using item utilities. Then items are arranged in the transaction weighted utility ascending order and utility list structures are created to store utility information. The leaf item set utility structure stores utility values of contiguous patterns and helps raise the threshold further. The algorithm mines top K high utility patterns by extending patterns and adjusting the threshold based on actual utility values. Now we shall see how this algorithm handles incremental data. Now, when new data is added, the algorithm scans the incremental data and updates the global lists and restructures them using the new data, recalculating the remaining utility for efficiency without rescanning the entire database. Finally, Top K utility patterns are mined from the updated global lists. This process efficiently handles dynamic data sets while minimizing computational overload. Various experiments have been performed, and the recent list-based Top K high-utility pattern mining algorithms were used for comparisons. The experimental results showed that the algorithm processed incremental databases faster than state-of-the-art static algorithms while also consuming less memory. Moreover, it demonstrated great performance in a situation where the size of the database became larger. We conclude that the suggested algorithm stores the minimum utility information of patterns by constructing list structures. Since the utility list holds the actual utilities of patterns, candidate patterns are not created, and thus additional database scans are not required. Whenever an incremental database is inserted, the algorithm updates and restructures its global list efficiently through a single scan, which results in less memory usage. Additionally, it constructs leaf item utility structure corresponding to this changed transaction weighted utility ascending order through the introduced restoring process and raises the minimum utility threshold efficiently. Therefore, this algorithm is suitable for processing incremental data. This is one method where list-based data structures are used for efficient pattern mining. Thank you for watching this video. I hope you found this video informative and learned something new. I have included the link of the research papers in the description. Don't forget to like and subscribe to my channel. Have a nice day.